properties. So properties are smart fields where we can get and retrieve some data which is stored in a proper format, so that we can provide our own validation. With that example, what we have seen in the last class, there is an age factor, and age can be an integer, but if a user wants to provide the data as 5,000 or some 10,000, so it should not be accepting, because age cannot be more than like 100. So in general, so you have to validate first of all. So how to do these smart work is by using these properties. So properties will ensure, as per your logic, they will try to put some restrictions on the data, whether it is allowed or not, and accordingly you can provide some validation. Okay, so how to use these properties? You have to simply create a property with this particular block, which is seen in this example. So there is a property name called as caption, which is data type of string. Okay, so in this it is having two blocks, one is get and one is set, where we can return directly if you do not want to manipulate the whatever the input data. Otherwise you can provide your own implementations also, and similarly set can also be implemented as per your requirements for the constraints. Okay, so in that way we can properly set and get data as per the business logic that you require for your own applications. So this is the importance of the properties. Okay, so properties are in general heavily used in all the all the object-oriented programming languages, and in C# also it is quite extensively being used. And if you see any of the object, suppose you are going to create a .NET framework class, when you call that object with some dot operator, all the properties are going to be listed out, which are the default properties. So those properties are also created in this way only. So the all those properties were actually created with this syntax only. So that is completely customizable. So some are own defined set of properties that you can use, or you may take the direct default implementation of an object given by the .NET framework. Okay, so we will see these examples when we go to the practical slots, and for the time being, the syntax you can see and understand. Then moving on to the variables, what are the variables and these primary kind of theoretical knowledge? I think all of you already know. Still, we are going to simply skip by clicking at a very faster pace. Variables can hold either the value types or the reference types. Okay, so there are only two kinds of variable types that you can store in the memory. One is based on the stack implementation and one is based on the heap implementations. So the stack implementations are generally value types, and the heap implementations are generally called as reference types. So this is across all programming languages, that is having the same concept. Okay, so a variable of value types directly contains only an object with the value. A variable of reference type directly contains a reference to an object. So that is the only difference. Okay, so value types directly they are having the values which are stored in the memory, in the stacks, and whereas the reference type is having the reference to a particular object location which is present in the memory. So that is only referred. Okay, so that's why they are called as reference types. The object data is somewhere stored, and that address being referred in a variable. Okay, suppose there is an address like there is a postal address. You want to meet some person, and that particular person address is at some Itavari. So you directly are not able to reach him, because first of all you have to go to the Itavari, then you have to find out as per the address given by him, particular lane number, house number, plot number, whatever. So that is in the same way, the reference types are being referred to a particular memory location in the computer application, which is being run in the particular memory location. So a variable, these two kinds of variable types are in general being used commonly across all the platforms, all the programming languages. Even C++ and other implementations also do the same thing. So it is possible in C# to define your own value types by declaring enumerations or structs. Suppose there are many default value types that are being provided by the C#. But sometimes what can happen, you want to create your own data type, either for the list of collections. Okay, so not that much heavy enough to represent that as a class. Okay, you don't want to take a class. It is simple enough, but even though it is not that much simple enough to take in a simple variable types that are provided by the .NET framework. So there you can take the help of these two particular features. One is enumerations and another one is structs. So the example for the different kind of value and different types are, we can see in this way. Here what we have discussed, there is an integer I which is having a value of 1 to 3. Okay, so the value of 1 to 3 is going to be directly stored in the stack value of 1 2 3 as provided in this screenshot. But whereas as string is a reference type, string in advanced languages is not a value type. If you take Java or C# or any other advanced programming language, string is basically reference type, because how many characters that the string will be having, beforehand you cannot identify, because at runtime the string may be changing to some quite higher dimensions. Suppose initially it was of 10 characters, then it is abruptly going to some 100 characters, then maybe some 10,000 characters, then again coming down to some 5 characters. So these kind of manipulations are in general common in all the applications, depending on your requirements. Okay, how you are going to manipulate the string according to your programmatic requirements. So what happens is, so if you provide that as a value type, so there is a limitation, because the value types are having a stricter boundary. It cannot go beyond that boundary. That can be some 32 bits or some that is entirely depending on the programming language. So every programming language is having its own value type range limitations. So depending on your data type, some language may take some 32 bytes or some 16 bytes. That information is completely variable as per the compiler, as well as the architectural requirements of that language. So that's why you cannot take this string as a quite 1,000 characters of length only, because if you are going to assign 1,000 characters and an user is storing only 10 characters, remaining 90 characters are going to be wasted out by the memory. So this thing we do not want to have in our application, because memory is precious and we want to store, we want to save the memory for optimized use of your application. Okay, so a simple variable holding that much of memory unnecessarily is going to have some problems for your own applications. The memory crunches will be there. The system may be unresponsive at sometimes. So these are the common problems that you find whenever you are not optimizing your code as per your programmatic logic. So that's why string is generally taken in the format of reference type. And reference types, as we have already discussed, it is only a pointer to a particular memory address. So that particular memory address is going to be maintained in this stack only. Then actual data is being maintained in a heap. So in that way we can have the implementation. So some of examples of the value types are primitive data types like integer, okay, boolean, then short, long, double. So all these are primitive data types. So primitive data types can be safely taken into the value types because they have a particular range. When you see any language, the ranges are being given. So for the integer, it may be like minus 32,000, 654 to some plus 32,655. In that way, some ranges are defined for each of the data type. Okay, so the primitive types are generally being stored on the value types, and similarly enums are also kind of containers which are actually combined on the basis of the data types which are primitive. So that means even though they are directly not the primitive data types, but the combination of the data types are entirely based on the primitive data types. So that's why you are actually combining those data types into a container, and that is for the listing of some some data. Okay, suppose you want to have some data of marks. So marks are combination of some integers. So in that way you can define your own data type for the enums, which is of the same data type. Okay, but whereas structs can also be the implementation for the value types, and the structs are generally stored on the stacks, because it is also some combination of the data types, and structs are generally seen as a smaller implementation in relation with these classes. Okay, so that's why if you are going to have a full object which is having so many properties, so many methods and functions, so generally it is being converted into a class. But if that functionality is somewhat limited, and you have a very minimalistic approach to that particular object, okay, even struct is an object, so you want to have some wrapper which is not that, which is not as much level as that of class, and not at the very basic level of primitive data type, then you can safely convert them into structs. Okay, so in another programming languages, maybe you might have done the practicals for these structs, enums, and primitive data types. So that's why broader explanation is, I think, we don't have to go through. And then coming to the reference types, reference types are, yes, the first candidate is the class, because when you create a good class, it is having so many methods, variables, properties, indexers, then methods. Okay, so all these are a combination of the implementation to expose the functionality of a particular class. So in general, when you create an object of a particular class, it may take or it may not take the memory as per the invocation of that particular object. Suppose you are going to call one variable, one method. In that method, some internal variables have been defined, and it is being calculated for a heavy complex operation for a mathematical calculation. So according to that particular object invocation, object method invocation, it dynamically tries to acquire some additional memory, and after method is properly completed, then it is going to be dereferred that memory location. So all these part of the GC, garbage collection. So it continuously happens in the background. Okay, so you whenever you are calling any particular object method, it is going to dynamically assign some memory depending on the variable and other declarations of that particular method, and properly execute that particular functionality. And after that is completed, the method variables and even the classes objects which is not referred anymore, they are going to be declassified first of all, then it is going to be deallocated from the memories. So that's why they have to be first of all taken onto the reference types. Then second candidate is interfaces. So interfaces are also kind of a definition that we want to have, so that the functionality can be achieved across some incompatible classes. If you are talking in terms of the compatible classes, then you don't have to take the interfaces, but there is some inconsistency between the implementations of the classes, then the best candidate is to go for the interfaces. So what does that interface is doing is, it is putting some kind of contract kind of nature, even though the objects are not similar. So that is what we have through that interfaces. Okay. So then comes with arrays, because arrays can be dynamically extended, or they can be shrinked as per the requirements of the program. So that has been also referred as a reference type, and you can see the implementation, because if I have defined an array with the string, so as we have talked, strings are anytime have to be converted onto the heap location. So array of strings are nothing but the heap locations only we are going to create. Then final one is delegates. This is a complicated thing to understand. We will try to understand more on this when that particular topic comes. So what are the delegates? Delegates are the secondary objects which does some work instead of from a primary object. So that exact meaning you will come to know when that implementation we are going to see. So delegates are like they are the second-hand players, and which are very easy to manipulate across some different objects. Okay, so these are the basic type systems that they have provided, and mostly you all know there are only two kinds of types that are basically referred. One is value type, and second one is reference type. Which types are actually value types and which types are actually reference types? Only those things you have to understand. So this is an example of how we can see the data on the memory location. Suppose there is an integer 17 and this integer value is being assigned to j. So what it does, what this j is doing is, it is not saving I, because I is an address. It is not saving I. Instead of that, it is saving the direct value onto the j's location. So in that way, if you say for example, if you are going to save some additional variables like j is equal to I, then k is equal to j, some m is equal to k, in that way. So all these are nothing but copies of the actual data. See here, copies of the actual data. So 17 here, 17 here, one more 17, maybe you are defining with some another variable. So the copies of the actual value are getting stored on the stack. Similarly, secondly, you can see if you copy a reference type here, s is equal to hello, and I am saving s1 is equal to s. So what it does, both are actually not saving the actual data, but they are being referred to a memory address. So this is some memory address. So memory address like ampersand, suppose some value is here. So the same address will come here. So address is being repeated, not the actual data of that particular string. So in that way, what we are doing is we are actually saving the memory location extensively, because this S is containing some 10,000 characters in the string format. Okay, so we are saving 10,000 characters. No need to save 10,000 here and again 10,000 here. You may take any combination of these all the combinations of these 10,000 characters, simply referred with a common address. So this is the common address that we can put here, and again one more common address that we can same address we are going to put here in the second variable name. So this is how the heap is getting operated. Okay, so what are the initialization values in both the cases? Initialize to 0 if it is an integer in the value types, or false if it is a boolean type in the value type. Okay, so these are some of the default initialization of the variables, and whereas in the reference types, in general, by default, if you have created an object and you do not have any variables that are still not yet initialized, or the object is not at least not invoked in the memory location, it is taking as null. Okay, then the assignment is actually copying the value, and whereas the reference is copies the reference. So these are the primary differences between the value types and the reference types. Getting? Yes, I hope everybody already knows this, but still we are covering, so that not to leave anything not covered. Then data types. So what are the C# predefined value types? There is a long list which you can see and go through. There is an S-byte which is having the possible ranges from -128 to 127. There is a short, so 32.7, some 768 to this particular range. This is short actually. Okay. In another programming language, this may be a complete integer, but whereas the .NET platform, the integer is having some lakhs of ranges, 2 to the power of 31 to 2 to the power of 31 minus 1. So this is a very high range for a normal programming application to work with. Unless otherwise you are not operating on a scientific kind of application, you may not exceed this particular integer range. Okay. So even though if you are going across those ranges, we have additional data type further along, which is sometimes double to the to that integer. You can see here clearly 2 to the power of 31 there, and here 2 to the power of 63. So it's a mind-blowing long number that we cannot see and understand also how much actually it can store. So those much of information also we can safely save if you are properly defining your data types. Unless otherwise required, only you are going to you are not going to take the higher data type. Suppose like with that previous example, if you are only going to store the data for any person's age, so what should be the ideal data type? The ideal data type should be not short, that is S-byte, because not on earth any person is there who is more than 127 years old. Even he is there, he is not going to use the computer. In that way we can understand. So the better to store with the less data type, so that to store optimize your memory, so that your application can extensively use that remaining memory available for your programs. Okay, so directly you will be having a like implementation, like taking integer I is integer age is equal to some 20. So why to take integer? Because it is already taking so much of range, like 2 to the power of 31. So if you are going to only store the age, why to take that integer? So don't take that. So this is all what the optimization is actually. So when you properly optimize your data as per your requirements, your application will be a very powerful application, and it will work in a very sophisticated manner, and with less time it can process more, because all the remaining resources are available to process, but you are already reserving the most of the memory and other things only to store the data which is not at all required. Then your application will hamper. So in that way we have to first of all consider, and then only go for the proper data type creation. Getting everybody? So that is a fundamental understanding before creating any data for your variables, or assigning any variables for your data. Then similarly we have the system.byte, which is again positive. This S-byte is for the negative as well as positive, but whereas is byte is a positive one. So it is a signed byte, it is a normal byte. So it is up to you which one to take. Then U short, unsigned short. So that's why unsigned means there is no negative value attached to that. So that's why it is double to this. Okay. So that means you want to operate some digits which are in positive nature. Then you can safely take U short, U int, so that the range will be doubled, because you are not going to extend on the left side. You are going to have the more range on the right side. Okay, so U long, U int, and so all these are unsigned ones. Then float, it is having some 4 bytes of information, and the range is given here. Double, it is having some 8 bytes of information, the range you can see here. Decimal, 12 bytes. Char is only 2 bytes, and bool is half a byte, because it can either store a true or the false. So in that way the basic data types have been created, and all these are actually C# data types, which are properly mapped to system common language compliant system data types, like int 32, int 64, system dot string, system dot double. So all these are actually mapped to .NET framework, data types. So whatever you are going to see here are the C# data types, which are properly mapped to a particular data type given in the common language specification in the .NET framework. So that's why it is actually able to run on the framework. Similarly, if you are going to see the VB will be having different data types with the same ranges, but the name is something different. But they are also mapped to some mapped to some common data formats as per the .NET framework. So then we can the examples are provided for the value types as well as reference types here, and there is a feature which is actually called as boxing and unboxing. What actually does is C# allows you convert any value to a corresponding reference type. Okay, suppose see this example, integer I is equal to 1 to 3. So this is a stack version. Then I am going to create a object named box, and what I am doing is I am simply saving this data into this variable. So now box is containing I, but I is actually an integer which is a stack. So this is a heap. Box is a heap and stack is a I is a stack. So directly you can check, like if box is in, then we can run some statements like this. What happens is sometimes runtime errors may get generated. Okay, so the data conversions are very stricter in C#. The data conversions are very stricter in C#, and still it will allow you to have some implicit conversions. Implicit conversions means, see this example. There is a value of integer data type. So this is one integer which is having the long value and which is being stored in this myInt. Now what I am doing is I am saving this variable into a higher order data type. So this is a higher order data type long. Yes, this can be saving this information because you can put a small box, you can put a small box inside a bigger box. So that is a natural thing. So similarly, a smaller value can be safely saved in a bigger data type. So that is what we call as implicit conversions. But when you do this kind of reversal operation, certainly there is going to be a loss of data. Certainly there is going to be a loss of data. To reverse this, okay, so with some long data type value you are going to put in this myInt, then certainly it will store something, but it's not the actual data, it is a junk, because the additional whichever overflown data is actually trimmed by the data type, and the remaining thing is nothing but the junk. So this will be the problem. So that's why the conversions we generally want to ensure stricter. Okay. So explicit casts are accomplished in one or two ways. There is a double here which I have defined, and what I'm going to do is I am going to put some typecasting so that the information is actually getting converted into an integer. So what it will do is it will simply truncate this decimal portion, and it will store the value as 1, 2, 3, 4. So this all you know. Okay, so but what is the mandatory thing is here to put this typecasting or explicit data conversions, what we say as explicit data conversions, exclusively in this kind of operations. And the second way of doing the thing is, this is from the C# mode. Okay, so int is actually data type of string C#. So this is one way of converting the data into the required format. And second format is also available, which is coming from the .NET framework. So this is a common format. This is the CLS compliant method. Okay, so convert dot 2 int 32, 2 int 64, 2 boolean, 2 string. Okay, so 2 double. So all these are actually the system defined, .NET system defined objects and methods which we can again use for the same case. So जैसे यहाँ पे value मिला है 1 2 3 4, so same is going to be given as that of value, but only difference is Here we have used the C# explicit language data typecasting, and here we are using the .NET framework methods. You can see here 2boolean, 2byte, 2char. So all these are the system level object methods that we can invoke on some data types, so that to get the proper data as per your requirements. And one more mechanism is there, which is to parse if any value is like parsable or not. If there is any error, then it can similarly suppress that error. Suppose there is a result which is pool result is equal to int32 dot try parse, and there is a value, and we are going to parse that number. Suppose if it get fails, error will get suppressed. So try parse is used for that manner. Okay. So the parse, if the conversion does not succeed, an exception will be thrown. So here the exception will be thrown, but here the exception will be suppressed. So both these possibilities are there. So you can take out any of these, so that if you are having any doubts, like the conversion may get failed, the conversion will get into some uncommon logical error. So if you are suspecting that kind of behavior from the program, you can safely take either the try parse or from the parse from this data type int32. So int32 is from the system. That means this is a .NET type of conversion. Okay. So three modes we have seen. First one is typecasting from the language. Second one is the same data conversion from the .NET framework. Third one is typecasting safely. Okay, so safely with having some errors generated exclusively, so that you are going to parse and raise some exception. Otherwise, even if it is raising some exception, it can be safely handled by this particular method try parse. Okay, so in that way we have some data conversions which are applicable. Then strings are immutable, and like with the case of the Java and other advanced programming languages, nowadays every programming language takes this string as a reference type, so that's why it is immutable. What is the meaning of the immutable? It can't be changed. Okay, so mutable. Mutation is not permitted. Mutation is not permitted means whenever you have declared some text like ABCD, some characters up to 50. Okay, so it cannot be like it cannot be sliced, or it cannot be combined, or it cannot be appended with any information. So these operations are not valid on the given string data type. But we definitely do all these operations. But whenever you are doing those operations, actually we are creating numerous string additional data types. So the original version will not get changed. The original version will be the same, and it is not going to be changed for all the operations that you make on the string. Like you are splitting that into half, you are adding some additional characters, you are finding from the 5th index to some 20th index, you are taking subtext out of the common string available. So all these permutations and combinations, whatever you are applying on the string, are actually creating additional strings in the memory. Okay, additional string variables in the memory. So that's why if you are well versed with C++ or C kind of syntax, generally we combine strings with the plus symbol. Okay, the first text, then applying the plus operator, then second text, then third, then a value coming from the variable. So in that way we are actually comfortable doing the string manipulation, but this should be avoided because this is going to give the performance penalty on the application. What it does is you are going to create so many newer strings out of this base string. Suppose you are concatenating 4 times, 4 additional strings and plus 5 the last one. So in that way, total 5 unnecessary string memory locations you are going to used or you are going to use in the application. So that has to be avoided. Then the strings can be indexed, the strings can be checked for the length. Then the string can be created either in this format or in this format. Both are same. Because why it is so? Because in .NET everything is an object. Okay, so every data type that you declare ultimately is a perfect object, because it is taken from the root object system.object. Okay, so this is the base class from which they have created all the data types, all the classes, all the libraries. So as it is completely an object, so whatever you are having in your application are nothing but the object representation. So that's why you take either this direct approach or the class kind of approach. Both these are basically creating a object with this value. Both are acceptable. Okay, so though the even though the syntax is different, both these representations are acceptable completely. And suppose whenever you are having some escape characters, you can take the help of the verbatims. So these are called as verbatim. And what it will do is it will simply skip out some of the escape characters exclusively from this string. So when the parser actually reading your string, you are going to have these see here, the example is here. Suppose this is an escape character and this is an escape sequence, this is an escape sequence. How to say that this is an escape sequence? There are two kinds of implementation. One is you have to put this \n. Okay, so that is one way of doing. Second thing is directly take the data as it is and simply provide with a verbatim symbol. So this is called as verbatim symbol. So this verbatim symbol, what it does is it will come to know some special characters are there, and accordingly it is going to parse. Here it is not going to see this as a new line. Here it is not going to see this as a tab. Why? Because it is checking with a verbatim. So thereby your data is not at all treated in another way. So that is the implementation of the verbatim. Okay. Then string to numbers. These are the examples. You can directly take some text in this way and you can safely convert into an integer data type, or otherwise you can parse a float into a data type. Otherwise you can take try parse also. If you are doubtful that at runtime this may get overflown by the ranges of the data type, then in those conditions you can take try parse. So what the try parse does, it can suppress, but simply parse is it will not suppress, but it will actually raise an error. So these are some string manipulations. So string manipulations can be achieved in this way, and there are some supported methods which are available called as string.format, in which format you want to have this particular data. Okay, so this is formatted for the currency. So the currency means the dollar symbol or the rupee symbol will come to there. So based on the culture of your computer, you can define your own culture. So by default, the dollar symbol will be taken because we have defined with a format specifier C. So and accordingly, your data will be printed as $1.23. So some string examples are there. You can